Okay, so for question 15, you have an acid-base neutralization reaction, and you are asked to write the balanced chemical equation for the neutralization reaction. So let's start off with what part is your acid, what part is your base. Acids, remember, you can recognize them because they have an H in the front or a COO group, COOH group in the back. So this has an H in the front. It's a covalent molecule with an H in the front. That's an acid. Bases, at least the ones we're looking at in this unit, they are metal hydroxide. So lithium's a metal, OH is a hydroxide group. So if you see a metal and then a hydroxide, that's a base. And what happens when they get together? Well, when they get together, they do a double displacement reaction. And so just to remind you, a double displacement reaction is this sort of thing here, where they sort of switch partners. And for acids and bases, the formula is pretty much the same. An acid plus a base yields a salt and a water. Acid plus a base yields a salt and a water. Acid plus a base yields a salt and a water. So when you see this, you automatically know what you're going to form. An acid and base, we're going to get a salt and a water. So let's see how that forms. The water forms from that acidic hydrogen reacting with the OH group. All right, so our first and last. So in that case, this is going to give us H2O or HOH, the same thing. I'm going to write it as H2O, but you can write it as HOH if you want to. Okay, so however you want to write it, this way or that way. All right, so we're writing, so now we've got our waters. Now let's get our salt. Our salt forms from the metal in the base and the nonmetal of the acid, nonmetal anion of the acid. So that's going to be lithium phosphate. Now remember, whenever you're forming a salt, also known as an ionic compound, you need to figure out the charges to make sure this is the right chemical formula. So phosphate, if you look in the table here for polyatomic ions, phosphate has its PO4 3-, so the charge on phosphate is 3-. And so I know that this has a 3- charge, and I'm just going to write this above it just so we can see. Now lithium is in group 1, which means it has a +1 charge. Okay, so lithium is in the periodic table. It's in that first group of the periodic table, has a +1 charge. All right, so now if I look at this and I say +1 - 3, oh, that's not a neutral molecule. The overall charge must be 0. Well, how do I get it to be neutral? I'm going to need 3 lithiums in order for that to be neutral. So I'm going to use a subscript of 3 by the lithium to show that this is the correct formula. All right. So now I've got my formula all done. All I need to do now is go ahead and balance it. Now, with balancing the acids and bases, you can do the same thing that you do for the precipitate double displacement reaction. So you list your cations and anions. For the acid, the cation is the H in the front, and we've got 3 of them. The anion is whatever left, PO4, and we have 1. Notice that I'm not putting any charges here because that doesn't help me with balancing, just maybe make things more confusing. All right, lithium, for the base, it's the metal and the hydroxide. So lithium, we've got 1, and we've got 1 hydroxide. Okay, I'll do the same thing on the other side. So the HPO4, Li, OH. Okay, I like to write it the same way that I wrote it on the reactant side, but you don't have to. You can write it as you see it. So if you wrote it as you see it, you probably put Li first, then PO4, HOH. And the HOH comes from the water. Remember, one of those hydrogens came from the acid in water. So this one came from the acid. And then the OH minus came from the base. So that's why I split it up that way. And with this, in this case, I oftentimes like to deal with the waters last, just because it just makes it easier. All right, so let's see how many lithiums we have. We have 3. We've got 1 phosphate, and then for each H2O, you would have 1 hydrogen and 1 OH. So since I have 1 water molecule, right now I have 1 hydrogen and 1 OH. Okay, we're going to balance the waters last because once again, it just makes our life easier. So that's what we're going to do. But you can do it however you want. So I'm going to start with the lithiums. I have 1 on this side and I have 3 on that side. So I'm going to change the coefficient here to 3. So I can have 3 on both sides. Now when I do that, that also changes my hydroxides to 3. Okay, so we're good with that. Now let's go to the phosphates, because again, I'm going to balance the waters last. I've got one phosphate here and one there, so the phosphates are looking good. All right. So now I look at my hydrogen and hydroxide, my H plus and my OH minus. I have 3 on the reactant side. Now, one thing that's important is that the number of hydrogens and OH minuses, or H plus and OH minuses, need to be the same, because if they're not the same, you're gonna you need one of each for water, so they just need to be the same numbers. So if I look over here, I say, okay, they're the same. That means that I needed to have formed 3 waters, right? Because each water has 1 H plus and 1 OH minus. So I know that on this side here, I've made 3 waters. So I just go ahead and put that in there. Okay. All right. So there we have it. This is the balance equation. So the key steps here: your acid, your base. Switch partners to form your salt and your water. Then to balance, you split apart your cations and anions. For the acid, the cation is the H plus, and then the non-metal anion. For the base, it's the metal and the OH. Then what you do is you do your tally, and a good strategy is to balance that water last. Focus on the metal and the non-metal part, and worry about the H and OH last. All right, that's it for this video. Hope you found it helpful. Have a quality day.